Lesson 6.5, trigonometric form of a complex number. You will learn how to represent and graph complex numbers in trigonometric form. A complex number is a plus bi. A is the real part, b is the imaginary part. We have an imaginary axis that we'll put on the y-axis, the real axis on the x-axis, and then you can plot the point using a and b. A would be how far out left or right you would go on the real axis. B would be how far up or down you would go on the imaginary axis. The absolute value of a complex number, a plus bi, is the distance between the origin, 0, 0, and a, b. If you have a complex number, a plus bi, and you want to know the absolute value of that number, you take the square root of the sum of the squares, a squared plus b squared. Trigonometric form, a plus bi, a is equal to r cosine theta, b is equal to r sine theta. So to write your complex number in trigonometric form, it would be r cosine theta plus r sine theta I, which you would put in front of sine, as you can see here. And you can factor out the r, so you can leave the r, the radius, or the distance that that number is, that complex number is from 0, the absolute value, also called the modulus. You can factor that out and just put your angle in here, cosine theta plus I sine theta. So to find r, remember it's the square root of the sum of the squares. And to find the angle, its tangent of theta is equal to b over a, similar to what you've already seen with vectors. That should look familiar. Plot the complex number and find its absolute value. So here we have, any number can be a complex number. You have your real part and your imaginary part. Well, if you want to write -7 as a complex number, it would be -7 plus 0i. So we really don't have an imaginary part to number 2. So to graph, to find the absolute value of -7, absolute value of -7 is 7. We all know that, right? To plot that point, or the -7, you go to -7 on the real axis. 1, 2, 3, 4, 5, 6, 7. So -7 would be here, and it is 7 units from the origin. So to plot the complex number 5 minus 12i, you go to the right 5 and down 12. 1, 2, 3, 4, 5. 1, 2. Okay, I've already got a point down here. So that's 2 pi. It only goes down to 10, so go down to 12. So the distance, the absolute value, would be from the origin to that point. And what we did, just to give you a visual here, we went out 5 and down 12. If you remember your triples, you can find the distance very easily by going by your triples. This would be 13, 5, 12, 13. But we'll do the absolute value. The absolute value of 5 minus 12i, it's supposed to be lowercase scripted, is equal to, that's also r, kind of like your radius, the square root of 5 squared plus -12 squared, which is the square root of 169. The square root of 169 is 13. So the absolute value is 13. The absolute value of that complex number would be r, which is the distance that complex number is from the origin. So here we have z, a complex number, -1 plus root 3i, and we have to write it in trigonometric form. So to enable to do that, well, first of all, you don't have to, it doesn't tell you to graph it, but let's just go ahead and graph it and see what that should look like. So you go to the left one and up root 3, and root 3 is, you can put it in your calculator and get a decimal number, or you can estimate. 1.7. So it's back 1, up 1.7, that right there. And to put this in trigonometric form, what we're actually getting to represent that location, that point, is we're finding the angle, we'll call theta, and r, the distance, the absolute value, which is the distance it is from 0, 0. So this would be -1 root 3, written as an ordered pair, or if you put -1 plus root 3, written as a complex number. So if we find r and we find theta, we can represent this complex number in trigonometric form. So r is equal to the absolute value of -1 plus root 3, which is the square root of a squared plus b squared, right? So r is equal to the square root of -1 squared plus root 3 squared. And that would be -1 squared is 1, root 3 squared is 3, square root of 4, which is 2. To find theta, tangent of theta is equal to b over a. So tangent of theta is equal to root 3 over -1, which is negative root 3. Tangent of theta is negative root 3 at tangent of theta is negative root 3 in two places, but since we have a visual here, you have to kind of know where that point is, and it's in the second quadrant, so that's how you get your angle. It's 120 degrees, or so theta is equal to tangent inverse of negative root 3, which is 2 pi over 3. And it's the way you write it. I didn't realize I had left that on there, so there you go. So 2z is equal to, remember the formula is r out here, cosine the angle plus I sine of the angle. So you're just going to plug in 2 for r and 2 root 3, 2 pi over 3, for your angle. And that is that complex number written in trigonometric form. So we have here a complex number again. We're going to represent it graphically and find the trigonometric form. So go over 2, up 2. So it would be 2 plus 2i. R would be equal to, remember, a squared plus b squared. So that's 2 squared plus 2 squared. It's the square root of a, which is 2 root 2. Tangent of theta is equal to b over a, that's 2 over 2, which is 1. So theta is equal to inverse tangent of 1 where? Theta would be equal to pi over 4, which is a 45-degree angle, right? And that makes sense. If you look at your graph, you can tell that this would be 45 degrees. Or pi over 4 for the angle. And the radius would be 2 root 2. That makes sense. So, your complex number written in trigonometric form would be 2 root 2 cosine pi over 4 plus I sine of pi over 4. Let's do that again. Number 14 here would be 4, 1, 2, 3, 4, negative 4 root 3. 2, 3, 4, and then negative 6.9. 1, 2, 3, 4, 5, 6.9, about right there. So we're looking for the distance that that point is from 0, which is r, from 0, 0. Or 4 minus 4 root 3 I. And then we need to know theta, which is okay, for r, we're going to do the square root of 4 squared plus negative 4 root 3 squared, which is the square root of 16 plus 48, which is 64. That would be A. So the radius is A. Tangent of theta would be negative 4 root 3 over 4. So that's negative root 3. And theta is equal to tangent inverse negative root 3. We're in the fourth quadrant, so that would be 5 pi over 3. So you have 8 cosine of 5 pi over 3 plus I sine of 5 pi over 3. So here we're going in reverse. We have the trigonometric form and we want to put it in standard form. So remember that A, the A part, which is the real part, is our cosine theta. So A would be 5 cosine of 135. And B is our sine theta. So B would be 5 sine of 135. So cosine, you could, if you want to, cosine of 130, you could work with fractions. So A would be 5 times cosine would be negative root 2 over 2 of 135. You could also get a decimal number, and then so that would be negative 5 root 2 over 2. And B would be 5 times root 2 over 2, which is 5 root 2 over 2. So you have negative 5 root 2 over 2 plus 5 root 2 over 2I. If you need to graph it, which we could have done that first, you might want to change that to a decimal number. Negative 5 root 2 divided by 2. So it would be negative 3.54 plus 3.54I. So that would be easier to graph. Okay, so this one, you would have to go to your graphing calculator. You would go to the mode and change it to radian mode and A plus BI. So you just do that at the mode button, radian mode and A plus BI. Do that real quick here. Go to mode, change degree to radian if it's not already, and right here where it says real, put it A plus BI. Second quit to go to the screen. You'll put in 10. Open parentheses, cosine 2 pi divided by 5, close parentheses, plus second, and then you have to put the I in there, it's down there, bottom, sine 2 pi divided by 5, and at the end you don't have to close parentheses, but we can. We would have to close the one that goes with sine and the one that goes that follows the 10. And if you hit enter, you get your answer. So that's how you would find standard form for a complex number that's given in trigonometric form. And you would just write that answer there for that one. Here you have a formula to find a complex number raised to whatever power. So whatever you raise your complex number to, you would raise the modulus, or r, to that, this number here, which is the distance that the complex number is from 0. And you would also multiply each angle by that same number, which is much easier than actually having to work that out by hand, especially if n is a large number, larger than 2. So we can see how to use that here. I will raise it, well, first of all, we have it to the first power, so then we'll raise it to the second power. So that's equal to 1/2 squared. Oh, wait a minute. Okay, so we don't have it in the right form to be able to just use it on this problem. It's in standard form, so we have to change it to trigonometric form. So in order to do that, we need the radius, or the modulus. Distance is from 0, so that's 1 squared plus √3 squared, and that would be the square root of 4, which is 2. I'm sorry, I have messed this up. Guess what I didn't do? I didn't distribute the 1/2. The 1/2 affects that. So z is equal to 1/2 plus √3 over 2i. Now I can find the radius. That's the square root of 1/2 squared plus √3 over 2 squared. Okay, 1/2 squared is 1/4. √3 over 2 squared is 3 over 4. 1 over 4 plus 3 over 4 is 4 over 4, which is the square root of 4 over 4. That's the square root of 1, so the answer is 1 for that one. And then to find the angle, tangent of theta is equal to √3 over 2 over 1/2, which is √3. And tangent of theta is √3 at pi over 3. So we now have z is equal to 1. We'll put a 1 there so that we can see how to use that formula. Cosine of pi over 3 plus I sine of pi over 3. So z squared would be 1 squared cosine of 2 pi over 3, because to multiply 2 times pi over 3 would be 2 pi over 3, plus I sine of 2 pi over 3. And you could simplify that. I'll leave it like it is for right now. Cubed would be 1 cubed. That would be cosine 3 pi over 3 plus I sine of 3 pi over 3. So those cancel, so it's c cubed would equal 1. Actually, it would just, to simplify it completely, cosine of pi plus I sine of pi. And then z to the fourth.
Today, will we be able to add it on to our...
You just add it on. Okay, so to perform the operation here, there's a shortcut. You can, to multiply these together, you can multiply 3 over 4 times 4, and then, well, just watch. 3 over 4 times 4. And then this would be cosine of pi over 3 plus 3 pi over 4, that in parentheses, plus I sine of pi over 3 plus 3 pi over 4. So we have 3, and then let's go to the side and add together pi over 3 plus 3 pi over 4. This common denominator would be 12. 3 goes into 12 4 times. 4 times pi is 4 pi. And then plus 4 goes into 12 3 times. 3 times 3 is 9. Be 9 pi. So that would be 13 pi over 12. And that will be the answer when you're multiplying two complex numbers in trigonometric form. Next we'll be dividing. So if here we multiply these numbers out front and then we add together the angles with each function, what will we do on 54 when we're dividing? What do you think we would do? Subtract, yes. Okay. So this would be 2 over 4 cosine of 120 minus 40 plus I sine of 120 minus 40, which is 1/2 cosine 80 plus I sine of 80. And that there should be parentheses there because that's a different answer if you don't put parentheses there. Okay, for part A, to write the trigonometric form, we'll look at these one at a time. So, for this one, R would be the square root of root 3 squared plus 1 squared. Square root of 4, which is 2. And then the angle, tangent of theta is equal to 1 over root 3, which is root 3 over 3. And where is the angle root 3 over 3? we're in, which quadrant? We have positive and positive, so we're in quadrant 1, right? So where is it root 3 over 3? At pi over 6. You can use, we can work with degrees or with radians. Okay, and then for the other one, so we have 2 cosine of pi over 6 plus I sine of pi over 6 for this one. Now we have to do this one. We'll do this out separately. So the radius is the square root of 1 squared plus 1 squared, which is the square root of 2. Tangent of theta is equal to 1. 1 over 1 is 1. Theta is equal to what? Pi over 4. So we have root 2, open parentheses, cosine of pi over 4 plus I sine of pi over 4. So then we have to multiply those two together, just like we did on the previous page for part B, perform the indicated operation, which was to multiply the two together. So that would be 2 times root 2, so 2 root 2, this would be part B. Part A. Cosine pi over 6 plus pi over 4 plus I sine pi over 6 plus pi over 4. Really just brackets there. So pi over 6 plus pi over 4. What, 12? 6 goes into 12 twice. 2 times pi is 2 pi. Bring down your sign. 4 goes into 12 3 times. 3 times pi is 3 pi. So 5 pi over 12. 2 root 2 cosine 5 pi over 12 plus I sine 5 pi over 12. Part C is to perform the operation without putting it in trigonometric form. Okay, so root 3 times 1 is root 3. First, outer plus root 3 I, inner plus I plus I squared. So that's root 3 plus root 3 plus 1 I plus, what is I squared? Negative 1? Negative 1. Okay. So we want the real part and the imaginary part. We have the imaginary part right here. The real part, we would have to put this together. So root 3 minus 1 is the real part, plus root 3 plus 1 is the imaginary part. Okay, so what we're supposed to do is compare this answer. And when I do this, I'm assuming you know how to multiply imaginary numbers. Of course, we look at that again in section 2.4. But if you need help on this, I can help you. But what we need to do is find the decimal number for this part, the decimal number for this part, and then come up here and find the decimal number here and here to see if they're the same. and compare them. So root 3 minus 1 is 0.732 approximately. Cosine of gotta put it in radian mode. .732. So I'm multiplying 2 root 2 times cosine 5 pi over 12. I get 0.732, and I'm going to multiply that times sine. And they match. All right, next, finding nth roots of a complex number. Another formula. So to find the square root, you would do square root of 16, and then cosine, the angle is 60 plus, do we want to work with 2 pi since we have the degree measure here? Wouldn't it be better to work with 360? Plus 360 times, here let's let k equal 0, times 0 over n, which is, what's n if I'm taking the square root? 2. Plus I sine of 60 plus 360 times 0 over 2. So that would be 4. Cosine, what? What would this be when I simplify? 30 plus I sine 30, right? So I didn't write the directions up here, but on number 90 you have to write it in standard form. So 4 cosine of 30, what's cosine of 30? 3 over 2. What's 4 times root 3 over 2? Which is 2 root 3 plus 2i. So that would be in standard form. We have to do k equals 1. So it's the square root of 16 cosine 60 plus 360 times 1 over 2 plus I sine of 60 is 360 times 1 over 2. Yes.
How do we get 2 when we get together? Where does that come from?
That's what, okay, this tells you what n is. N equals 2. If it's the cube root, n would be 3. And then we have to do, if n is 2, we have to do k equals 0 all the way up to n minus 1, which is 1. So this will be 4 cosine, is it 210? Cosine 210? And if we wanted 210, 7 pi over 6. So 4 times 7 pi over 6 plus 4 times, what did I just do? That's not right. It's not supposed to be 7 pi over 6. Cosine of 210 is negative root 3 over 2. Not the angle. And then 1/2, negative 1/2, which is negative 2 root 3 minus 2 pi. And that's all you have to do on that one. If you have one that says cubed, you would do the same thing, except for this. This will be the cube root of this number. This would be a 3 here. This would be 0. This would be 1. And then you would have to do it one more time for k equals 2. And that's all. Yes?
Why do we do it so many times? Like, why do we add it? Why are we doing that?
Because that's part of the formula, you're having to find the different roots. So you're just finding the roots. It says, find the indicated roots of the complex number. And that's what we did.